This is our video for Module 3 on missing data. I'm going to be talking about data that I collected in my senior year of undergrad. It's on supervillains and how they fit into the 5 models of abnormal psychology. So, Allison, what are you going to talk about?
I'm going to be talking about the data set from the MSRP, which is the Miami School Readiness Project, which is part of my lab group that we work on. It follows 40,000 kids since their kindergarten experience started, and we look at a lot of different variables. And I pulled from this larger data set variables that show the students who showed up to kindergarten, then their ESE code, so if they have an exceptionality, and that's coded into different variables based on what the exceptionality is. So if they're autistic, they have their own group. If they're gifted, they have their own group. I also have their mean grades in kindergarten, so this is a 1 to 3 scale score of their grades. And I have the number of times they were tardy in kindergarten, which is turned into a range variable because the variability is really high. It was anywhere between 0 and 169 times tardy in kindergarten. So in this data set, there are real people. They exist in Miami-Dade County, and it's a longitudinal data set, so obviously we have a lot of missing values, and that's missing data.
So yeah, like she said, missing data is whenever you have no numerical value for an observation for any sort of reason.
So it could also be that a participant doesn't have a disability. So in my case, if they don't have an ESE code, then they would have missing data because they don't have that. It could be that they didn't show up for kindergarten, or if they did go to kindergarten, they were not in an MSRP school, so the school chose not to participate. Or they could have been in an MSRP school to begin with and then moved out of that school in the middle of the year, so they would have shown up but didn't have end of the year grades. And there's other larger systematic reasons, like not being in Miami at all. So people who are not in Miami are obviously not in my data set. And these are like bigger systematic reasons, and these can all be based on free choice or not. So it could just be the fact that our research scope doesn't go beyond Miami, so people are not in it just because of their location. Or it can be like a lack of funds to draw from the population. In this case, the funding was specifically from Miami-Dade County, so that's where we have the population at. Or schools could just decide not to participate. And so that's a little bit about my data set. What about you, Lydia? What about your villains?
So our data set, we were looking at 50 villains, 25 from DC and 25 from Marvel. And we were looking at the 5 models. So again, the behavioral model, humanistic, psychodynamic, psychosocial. And we were trying to see, we rated them based on criteria that we came up with ourselves. And the missing data comes from 1 or 2 things. It was either that the villain themselves did not have enough of a backstory for us to really look into rating them based on the criteria we came up with. The second reason is that since there were only 3 of us, we really wanted as many villains to have 3 full ratings. And if one of us didn't know it, we omitted that villain because, again, we wanted an equal amount of ratings for each of the supervillains. So yeah.
So missing data can have a huge impact on the associations that are made between variables. Other issues include using appropriate assessments when missing data are discovered. If they show like a non-linear or skewed relationship, or if they have like a non-normal relationship, we can use non-parametric statistics, but that takes a lot of effort and knowledge that they exist. And the article by Rasmussen and Dunlap states that the data transformation in this case is more effective with non-parametric statistics rather than stuffing the raw data through parametric tests.
So what are the options to handling missing data when they show up?
So the first and best option is obviously finding the missing data and inserting it into your data set. So if you have a survey and you just forgot to add this one participant's answer, you can go back and be like, hey, I know the answer, and I'll put it in there. But that doesn't always happen because you don't always have those surveys or the missing data at your hands. So another option that SPSS uses is listwise and pairwise deletion.
So in the listwise deletion, a case is dropped from an analysis because it has a missing value in at least one of the specified variables. And the analysis is only run on cases that have complete data sets. So in my data set, if I wanted to look at one of the models, so the humanistic model, if one of the villains, like Sapphire, which I think is the first villain that was missing, in a list-wise deletion case, it would delete Starfire all completely and not just that one data point for the humanistic model.
And that would be more like a pairwise deletion, which occurs when a statistical procedure uses cases that contain missing data, but the procedure does not include the particular variable when it has a missing value if they're trying to make a comparison between those values. So it can still use a case when it's analyzing other variables with non-missing values. So in my study, like if child 3 has missing data for ESE code because they don't have an ESE code, we couldn't use that when we're looking at ESE codes and mean grades at the end of the year because it doesn't exist. But we could look at the times tardy and the mean grades at the end of the year to see that relationship because they have both of those data points.
Yeah, so imputation can also be used. Imputation is a process that replaces mis-substituted variables. These values can be derived from a probability score by replacing it with the mean, regression imputation, or multiple imputation. But since neither of us used imputation, we're not really going to go into too much detail about it in this video.
So now we'll be moving on to our EDA, which is our exploratory data analysis. I'm going to go ahead and go first. But EDA is used to help a researcher understand and interpret their data set better. It can be used to show the initial distributions of the data for the variables of interest and to inform researchers if we need to use the non-parametric analyses, or to inform us if we have missing data, or if there's an incorrect value in place of something else, or if there's outliers in our data set.
And it is really important to display data correctly and interpretably.
It is the duty of the researcher, as stated by Ehrenberg in Rudiments of Numeracy, as those who present data, aka us, that we do it in ways that make it easy for those who are interpreting it to understand. So if researchers do not present their data well, it makes it harder for those who are trying to understand what we're talking about, understand.
So Weiner expands on this in his satirical article on bad data displays. Readers that unhelpful displays of data, especially those that add to the confusion, make it even more difficult for researchers to get their point across. With the importance of our research in the social sciences, it is vital that we attempt to get samples that represent the population, that also attempt to account for any missing data and display the results clearly to have maximum impact.
Right, so now that we know what an EDA is, I will hopefully be able to show you what I found. Here is my attempt K variable, the original ESE codes, then the recode to show if they have an ESE code or not, so it helps to decide where I have the missing data. The number of times tardy original variable, and then the range variable that I recalculated, and then their mean grade in K. And since there was literally it went up to the hundredths point, I recoded that as well into a range variable, so it was just 1, 1.5, 2, 2.53, which is 3 being the highest is very satisfactory performance. And then I have all of the ESE codes that are possible that show up in the data set. So like kid with autism right there. Yay. All right. So, and then, so first I ran descriptive statistics. I ran frequencies to see like the mean and median of all of my variables of interest. So this is the tardies, the range variable tardies. So it shows you how many I have and then how many kids have missing data. So over 9,000 of them, almost 10,000. And then it shows you the mean. So most kids fell within the range of 1.18. So that's the score number 1 is anywhere between 1 and 10 tardies. So it kind of makes it more difficult because you have to think about it within that range rather than the actual number of tardies. And then you see the median is off of the mean, so we can kind of assume that it's skewed. And then it also tells me down here with the skewness of 2, that's pretty high. And then we have the grades in K. So we have over 30,000 kids that have data for the end grade of K. And then there's about 9,900 that are missing, so almost 10,000 again. And that's because kids move out of the data set and other things that cause them to have missing data. Again, the mean and median are slightly off because we have a high skewness, which is, well, not very high, but it's actually negative. But it's still enough to make it look funky within the display. It's actually a bimodal distribution, but we'll get to that in a minute. And then we have gifted, which is my variable of interest because that's what I'm doing my master's thesis on, so gifted and talented education. So we'll get into them a little bit later when we look at them specifically versus the population. All right, so here's our frequencies. This is the range variable again, so you can see that most of the kids had a score of 1 on the range. So again, that's between 10 and 1, or 1 and 10 tardies throughout the whole school year. So that's our number 1 right there, is a big part of the population only had between 1 and 10 tardies, which is probably a good thing. You don't want them to have a lot because that's not good for their educational outcomes. And then for the grades, again, this is the recoded variable. So we have most of the kids getting around a 2, which is like an average. That's like a middle of the road score. But then you have more so on the top layer. So like 2.5 and 3 definitely got a lot more than the bottom part of the distribution. So that'll probably give us an interesting looking graph as well. And then for gifted, there's only 529 kids identified as gifted in kindergarten. So that's kind of an easy one because it's either you are or you aren't. There's not much of a option. You can't be somewhat gifted. All right, and then here's the data displays for tardiness. So again, you can see that a lot of kids are tardy between 1 and 10 times or 0 times, and then it kind of goes off in the negative or in the positive skewness direction. And then your mean for grades. Again, most people get about a 2, which is what we saw on the graphs. And then gifted, because you either are or you aren't, makes it really easy. All right, so first I ran a regression because I had a thought about what the relationship would be. So I assumed that there would be some sort of relationship between the number of times tardy in kindergarten and their mean grades. So my R-square shows me that 1.2% of the variance in mean grade in K is explained by times tardy in K. So that's pretty interesting. It's only 1.2%. So there's obviously a lot of other things going on that are helping explain these kids' grades. The ANOVA box shows that my model is significant. And then my significance in the coefficient box tells me that the IV of times tardy, or the independent variable of times tardy, does help predict mean grade in K. All right, and then moving on, I did a correlation to look at that relationship a little bit further, and it shows that they're negatively related, so the more tardies you get, the worse off your grade is, which is what I kind of expected. And it's significant because it's at the 0.01 level, so I thought that was a pretty good interval. It chose it for me, so I really didn't have much of a choice, but I still think it's interesting to see that the significance level is pretty high. I mean, not as high as I would like it to be, but it's still enough. Draw some conclusions there about tardiness having a negative impact on grades. And then finally, I did some exploring with the Explore tab in Analyze and SPSS. And I was looking at the entire population for grades and tardies because I wanted to see that in relationship to the times tardies and grades for kids who are gifted. So this is the original with the entire population. And then what I really was interested in is, go down, the times tardy, oops, yes, this is it. So there's that's the times tardy for the entire population. So again, it shows us most of the kids are only tardy like 2 times or less. So that's part of the range variable. So between 20 times and 0 times is the most. But this was my most important one because I saw the bimodal distribution of grades in K. So look at this huge peak for 2 and this huge peak for 3, showing that bimodal sort of distribution. And I thought that was really interesting, and it shows you like how much that teachers are passing kids, and they're pretty much either getting a very satisfactory or highly satisfactory score, or they're getting, their average, and then you don't get very many kids who are failing, which is probably a good thing. But that is important to me because of its relationship to the gifted variable. So when I look at the gifted like as a factor, and then times tardy and mean grade as my DVs, it looks more intense for those kids because they're not getting the grades that I would expect them to based on their educational possibilities, as I like to call it. So let me scroll down here. So here is the histogram for their mean grades for gifted kids. And you don't see that peak at 3 like you do in the other histograms. So I thought that was really interesting. And that makes me think that gifted kids are having either some sort of motivational issues, a stress issue, something else is going on at home where they're not achieving as well as kids who are not gifted or in the general population. So unfortunately, I cannot answer these questions with my data set, but EDA has allowed me to find them and to pursue some sort of future research that I may not have considered if I had not explored my data. And so that's all from me. Let me go ahead and hand it over to Lydia so she can tell you what she found about her villains.
All right. Okay, awesome. Okay, so for my data set, I'm just going to explain the variants a little bit. The rater, there was 3 raters, so you have 1, 2, 3. The villains, for each rater, they're all 50 are listed at once. So you have your first 50 and then it repeats. The medical and the psychodynamic, the humanistic, the behavioral, and the psychosocial, all these models are based off of criteria that we came up with, and each of the numbers represents how many criterion those supervillains fit into. So it ranges from 0 to 5. And if you have a 0, then you fit into 0 of the, you meet 0 criteria from the model. And if you have a 5, then you meet all 5. The publisher, you can either have DC or Marvel. And we looked at gender, male or female, human. They have human, non-human, and human transfer. And age, there was 4 periods when comic books were, I guess, popular. And I'll go into detail about that in a minute. So whenever we were going over this data in undergrad, we were really interested in seeing how the villains vary based on the model, also based on the publisher. So would DC villains have, like, would they fit, which model would they fit into versus the Marvel model, Marvel villains? All right. And to start off, I also ran frequencies. I wanted to see the mean, median, and mode, and also to see how many observations we actually had missing. So out of the 150, there was 16 missing. Most of them were females because there was not enough information to look at the females who were villains, mainly because we couldn't think of too many. One thing that caught my eye, which I now know, thanks to looking at the data, is I was expecting all the minimum ranges to be the same, 0 to 5, since that was the number of criterion you can meet. But when I looked at the data itself, I saw that under the humanistic model, the lowest score was a 2. And for the psychodynamic, the lowest score was a 1, which I thought was kind of interesting. So this is, again, just the frequencies. The humanistic, out of all the models, had the highest amount of villains in its model. They all had about 4 or 5. I met 4 or 5 of the criterion. The behavior had a relatively normal curve, and the psychodynamic, I only ran 3 of the models because I figured it would take up too much time to do all 5 of them. The publishers, there was only 2, and there's a somewhat bimodal distribution here. The ages, so they have the gold, which is the 1, which is 1930 to 1955. 2 is the silver, which is 1955 to 1970. 3 is 1970 to 1985, which is the bronze. And 4 is the modern age, which is 1985 till now. And so the 2 age periods that you see across most of these 3 models are the 1955 to 1970 and 1985 to present day. So the silver age and the modern age are the 2 most common comic book ages. Next, I ran a correlation. I wanted to see how well the models were related to each other along with age and the publisher. I was really curious to see that if they fit into one model, would they fit into the other ones that had similar criteria? And what I found out was that the humanistic and the psychodynamic had a significant correlation, which I thought was kind of weird based on what we came up with criterion. So some of the humanistic criterion were that they had goals they wanted to fulfill, they had self-esteem issues. And for the psychodynamic, it was more about relationship and childhood trauma, which I thought was kind of weird that they have a significant relationship. However, I was not surprised to see that age had a significant relationship. One of my hypotheses was that based on the comic book age, when the stories were written, that would have influenced where the supervillains fit in the models, because if there's a bunch of different wars or, you know, some drugs like in this in the 60s and 70s, I figured it would have something to do with how the authors were writing these supervillains. Also, I was not surprised to see that the publisher in the comic book age had a significant correlation, because based on whether it's a DC or Marvel, and when it was written, it seems like again, the characterization of these supervillains would be different. Next, I ran crosstabs. So I wanted to see, crosstabs gives you the count of how many how many villains were actually in that category. So I looked at the models along with publisher and the age. So, for example, DC and Marvel both had the highest amount of supervillains in the, at least met 4 criteria for the psychodynamic model. They also had about 57%, 57 met 3 criterion. One thing, and here's just a graph to kind of show it. Marvel's in green and the DC characters are in blue. So you can see that relatively they're really close to each other, where they have similar criteria meeting. The age, again, it just kind of shows you how many fit into each of the age groups. Again, the silver and the modern age, which are the 2 that had the highest peaks, have the most villains fitting in or meeting 3 or 4 of the criteria. One thing that caught my eye, though, also was this Pearson R and their Spearman correlation. The Spearman correlation is the non-parametric version of Pearson's R. And while the Pearson R is not significant, the Spearman correlation is, which kind of reminded me of the Rasmussen and Dunlap article, where they talk about how non-parametric tests can sometimes be superior to parametric tests when you have non-normal data, which is what we have. So it might actually be more useful to use the non-parametric test in this case. And here is the bar graph of the psychodynamic models and the times, the age period. So again, most of the villains fit in between 3 and 4 of the criteria, and you can see that 1970s, like 1955 to 1970 and 1985 to present, are the highest pretty much among all the criterion. So I'm going to kind of just skip through these because they all show the same thing. Again, Marvel and DC don't seem to differ too much in the humanistic model. And another thing.
Oh, I don't have internet.
Oh.
Go ahead.
Okay.
Do you have any?
I think I do.
Yeah, you do. You're good.
Okay, wait.
It's back.
Okay, I lost my output. There we go. Okay, so the Pearson R and the Spearman are both correlated, which means that there is a relationship between the age and the humanistic model. And finally, the behavior model is the last one that I ran the crosstabs for. You can see that the DC and Marvel are relatively close. There is again a significant Spearman correlation, which would show that the non-parametric correlation test would be might be a little bit more superior than the parametric test. Fine. Okay, and this is again between the age and the behavior model, and there's no real significant relationship, even though there is most of the villains fit in between the 2 and 3 criterion of the model. Finally, I did the Explore tab for the gender and models as well. I was really curious to see how the villains fit into the models if they were male and female. The one big problem is that we only have 5 females. It's technically there's 15, but since there's 3 of us, there's really only 5 females. And compared to the 20 males, it's not a fair assessment of how they fit into the models. So that's one thing I would like to work on if we continue to do research in this area. So yeah, this is how it looks. Most of the male supervillains fit or meet between 3 and 4 of the criteria for psychodynamic, whereas females fit mostly between 2 and 3. And this is the box plot, which you can see that most of the females just have some outliers where the males have a bigger range. And not surprisingly, the males have are between 4 and 5 criterion, and the females are not far behind them, which is not surprising, seeing as the humanistic model is the most common model for the supervillains. And they're pretty much equal with a few outliers. And this is a behavior model for male and females. The females have pretty much it's not much of a distribution. They look the same. And whereas the males have, there's a somewhat normal distribution, even though it's skewed. And yeah, looking at the data, it showed me that we really need to look at our criteria a little bit better and maybe work on specifying them a little bit better so that they're not as generalizable and they actually have some difference. I don't know if anything else, but also I would like to again compare male and female villains and maybe come up with a few more females so that they have somewhat of a difference. And I would also kind of like to look at the authors of the comic book villains based on the publisher, because that's one thing we didn't account for, that maybe the publishers and authors would have different just characterizations of how they would characterize their villains.